Hi Year 10, second video here on volume of similar shapes. I'm going to run through some examples and set you going on some Hegarty tasks. So listen to the video for the instructions. So volume of similar shapes. Very similar to area similar shapes, which will all be complete by now if you're watching this video. And I'm just going to run through this as our first example. So firstly, you start off with the length scale factor, which will be the larger length divided by the smaller length, so the length scale factor is 3. 9 divided by 3 is 3. The volume scale factor, this is what's different here, is the length scale factor cubed, which is different to before. So 3 cubed is 27. So to get from here to here, we cubed it. Okay. So then we have a look at this. We've got the length scale factor is 3, volume scale factor is 27. So we've got the volume of the smaller prism, which is 15 centimeters cubed, and we want to find out the larger one. So because we're going from the small to the large, we times by the scale factor. So we times by 27. So you do 15 times 27, which is 405 centimeters cubed. Another really similar example. So here we've got the two lengths, so we can find out the length scale factor. So this is the bigger length divided by the smaller length, 6 divided by 3, which is 2. Now the volume scale factor, okay, we cube 2 to get the volume scale factor, so it's cubed. I'll write this here just to remember. So 2 cubed, 2 times 2 times 2 is 8. So we've got the pyramid A, the smaller volume of 26. We want to find out B, so we multiply by 8 to get the volume of the larger pyramid. Okay, so here we would do 26 multiplied by the volume scale factor, which is 8, which gives us a volume of 208 centimeters cubed. So two really similar examples here, a third coming up. So in this example, we've got both the lengths again, so we can find the length scale factor. So we do 24 divided by 4, which is 6. And then the volume scale factor is the length scale factor cubed. So 6 cubed is 216. I'll write the 6 cubed here. It might be a nice way of remembering it if you like writing it like that. It's 216. So that's the scale factor for the volume. So here, this time slightly different. We've got the volume of the larger cuboid, and we want to find out the smaller one. So this time we divide. So be careful when you multiply by the scale factor or divide. So here we're dividing by 216, or 6 cubed. So we do 1728 divided by 216. So our volume of the smaller shape is 8 centimeters cubed. So now guys, can you please go on to task 618, volume of similar shapes 1, watch the video, make notes from the Hegarty video, do their examples and have a go at the task, okay? So pause this video here and then when you're ready and done with that one, you can resume the video. So guys, hope that task went well. We are now doing a few more examples to get you ready for the next Hegarty task. So this time, exactly with area, the step up here is that we've been given both the volumes this time. So we've got the volume of the larger and the smaller. So the volume scale factor is what we can find out first. So we have to do 8,000 divided by 1,000. Really nice and easy, which is 8. So the length scale factor, so last time we had to cube it to go from the length scale factor to the volume scale factor. So the opposite of that is we've got to do the cube root of that answer to get there. So the cube root of 8 is 2, because 2 times 2 times 2 is 8. If you want to check any of these answers, do check them on your calculator. So just to summarise, before we get to the answer, we've got the volume scale factor here, between here and here, as being timesing by 8. And then the length scale factor as being multiplying by 2. Okay, if we were going the other way round, from the bigger to the smaller, we would divide by 8 for the volume and then divide by 2 for the length. So look at the problem, you need to find out what y is. So we would do 20 multiplied by 2, which is 40. And because we're talking about a length here, it'll be centimetres. Another example really similar to this one, which will set you off on the next Heggerty task. So they're similar shapes, so that's why we know there's a scale factor. The volume of the smaller shape is 4 centimetres cubed. The volume of the larger one is 500 centimetres cubed. So to figure out the volume scale factor, we do 500 divided by 4, which is 125. And then to find out the length scale factor, we cube root that answer. Absolutely fine to do that on your calculator. So the cube root of 125 is 5. So that's our length scale factor. So then it says calculate the height of cylinder B. So we know the height of the smaller cylinder. We want to find out the bigger one. So we know we have to multiply by the scale factor. And because it's lengths, we times by the length scale factor. So we do 5 multiplied by the scale factor, the length scale factor, which is 5 also. So the height is 25 centimetres. Okie doke, guys. If you get on to Heggerty again, you can complete the task volume of similar shapes 2. Remember to watch the video because they add some really good examples and some notes that I want you to make. So far you don't have any notes if you don't make the notes from the video. And then complete the task. I hope this helped, guys. I hope you had a good lesson, and I will see you next time.